Oh, hi. Welcome back to our class in transportation planning, analysis, and technique. Okay, plan 258. Right. So today's agenda. mm, we will discuss about game theory. Okay. See. Mm, okay. Can you see the screen? Right. So this is the past weeks we have discussed about decision theory. Okay. And after that, we discuss about risk analysis, okay, and utility. And last week, we played the games. I hope you remember. And then today, this is our plan, okay? So non-cooperative games for zero-sum games and non-zero-sum games. At the end, I hope we have time to discuss about threat and credibility. Uh, can you hear my voice well? No problem. Okay, good. So start. Hmm. So you can follow this slide in Moodle. Okay, so let's start with the modeling zero-sum game. Can you see my slide? There we go. Yeah. Okay. So in this slide, I would like to introduce again about how we model. So I'll not discuss about the solution yet at this point, but I will show you how to model first. And after that, we will discuss about the solution. Okay. So in game theory, okay, you will have a lot of practice about what is single matrix games and then what is the meaning of the matrix. And I hope you can develop your own matrix for your purpose, including your project. Okay. Okay. First, this is what is called a payoff matrix for zero-sum games. Okay. So we have two players. Okay. Number one is I will call this Miss Row, and then the second player I will call it Mr. Column. Okay, so Miss Row has two choices, alternative, okay, of action, okay, A and B. Mr. Column have again two alternative of action with C and D. Okay, so this number in here, okay, represent the payoff for Miss Row. Okay. So when you see the positive payoff, yeah, meaning that Miss Row will gain from Mr. Column. When you see negative payoff here, mean Miss Row will pay to Mr. Column. Is there? Okay. So there's only one number here because this represents zero-sum games. That means when Mr. Row gain, Mr. Column lose, and vice versa. So this is first type of the games. Okay. So now if Miss Row select A, yeah, and then Mr. Column at the same time select C, then Miss Row will get 4 here. Okay? That means Mr. Column will lose 4. Similarly, if Miss Row select B here, okay, and then say Mr. Column select D, okay, that means Miss Row will lose 5. Yeah? That means Mr. Column will win 5. Okay, so and okay, uh, what does this payoff matrix mean? Anyone have idea? All 0, 0, 0. What do you think? So, payoff matrix does not mean you just play one time. Remember last week, you play many times, okay? 8 times. Yeah. So, this is the expected payoff. Okay. So, that means expected payoff will be 0, but its games probably will not be 0. So remember, in we have our payoff matrix. 0 does not mean actually its scale will be 0, but this is the average. Okay. Now next, yeah, this one. Yeah. So how about this one? What does this payoff matrix meaning? 2, 2, 2, 2, 2. Mayan? Oh, Katrina. Okay.
Prof, I think for this game, Miss Row has all the gains.
Miss Row
Will gain
yeah,
in
Miss Row will
each
always win
scenario.
2 units.
Mm.
Okay. And Mr. Column will always lose 2 units. Whatever alternative for Miss Row and Mr. Column, okay, Miss Row is always win. So this is something that this is the game that Mr. Column does not want to enter. Okay. Of course, Miss Row is willing to enter this game. Okay. Next, how about this one? Yeah. So how about this one? So this is an example, okay, that even though we have 2 players, okay, the 2 players is not necessarily human or a company, right? So in this case, the second player result here represent the nature, similar to a decision analysis last time. Okay, so this is the oil company, oil drilling company. Okay, so and this payoff is in $1 million. Okay, so the oil drill company has 2 possible action. Okay, to drill or to sell the equipment. Okay, so if the company decided to drill, okay, and it has no oil, the company will lose 7 million. Yeah, but if it has oil there, okay, the company will earn 10 million. Okay? And then if the company decided to sell the equipment, okay, of course, it will gain $1 million. Okay? But if there is oil, if there is no oil, okay, if there is no oil, actually, even though the company sell the equipment, it will lose opportunity like $5 million. Okay? So that's the meaning of this payoff matrix. So this is the example where the Mr. Column is not necessarily a human player, but this is nature. Okay. Now, can you practice, rock scissor game, rock scissor paper games? Can you develop a game matrix for rock scissor paper? Okay, and you can show, you can share your screen. So you can set any numbers, as long as you know that positive mean gain, negative mean lose, right? Draw means 0. Anyone want to share screen? Go ahead. Yeah, Angelo. Sign.
Share my screen.
Okay.
So rock, paper, scissor on the rows, and then rock,
So,
paper, scissor on the column,
against paper.
and then
And
0 for rock, rock, paper, paper, scissor, scissor, and then if rock on the row, and then paper on the column, the point goes to paper.
yeah,
So it's negative for rock. And same here, rock versus scissor, rock wins. Then paper versus rock, paper wins, so it's positive. Then
1. Yeah.
paper versus scissor, so paper lose, so it's negative 1.
Yeah.
Scissor versus rock, so scissor lose, negative 1.
So
Scissor
it's
paper,
negative. Okay.
scissor.
Okay. So this is the game where when one player win, the other one lose.
Yes.
Or draw, of course. Very good. Okay. So now I have another problem for your practice. The next one. Okay. Uh, mm, mm, oh, I can move. I cannot move this screen. I will just share this. now I have two nation. Okay, so let's say the two nation is again the name is row and columns. Okay, left and right. Okay. And these are the roadmap. Okay, and these are the alternative of the path for row, and these are the alternative path for column. So you see here, path for row nation, okay, is through B. That means through this line, okay? From the row to B and then do to column, right? When we said BAC here, so the row will go to B and then going down here to A and then going to C and then attack the column nation. Okay? When we said BACD, okay, that means from the row, go to B, and then to A, C, and then going to D, and then attack the row, the columnation. Okay. While the part, and so on, yeah? And then while the part for column is only this part, okay? So when we said B, that means from column, and then going to B, and then going to the row. When we said BA, that means from column, going to B, to A, and then attack the row nation, and so on. So my question to you is simple. What is the size of the game matrix? What is the size of the game matrix? Anyone? Yes, Angelo.
Prof, is it 4 by 4?
4 by 4, why?
Because there are 4 unique routes
Oh,
or stations.
okay. It's not correct. Why? Oh, yeah, Japan.
Sir, is it 9 by 5?
Is it 9 by 5? Why 9 and by 5?
Row versus column, sir.
Correct,
Combination.
correct. So it's supposed to be actually 8, huh? 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, 9 by 5, correct. So the value is supposed to be like this, huh? So these are the possible path for row, okay? And these are the possible path for column. So when you see the problems, okay, how you model is look for the possible path for each player. So and when we said here, for example, here -8, okay, that means what? The row, if the row use this path, yeah, PAC, and then the column use PA, okay, that means the column will win 8 units. Okay. And in here, if 3 here, if the row use this part, yeah, DCAP, and then the column use this part, which is CD, then row will win 3 units, but in the column lost 3 units. Is it clear? So now another problem for practice so that you gain understanding is the next problem. Yeah. So in this problem, we have maze, okay, cat and mouse games. Okay. So the mouse will enter from this side. Okay. On the top, right? And then the mouse will enter from this bottom, and the cat will enter from here, the top. Okay. And then they only can travel at the same speed, okay, for only 3 consecutive steps. Okay, that means only 1/4 of the maze. Okay? After that, the mouse will be rescued if the mouse still alive. Okay, they got it? So again, the same question. How many is the game matrix? What is the size of the game matrix? Can you make that game matrix for this cat and mouse? Any idea? No idea. Do you understand the problem? We have a puzzle, okay, with this maze. The cat enter from here and then just turn 3 times, three turns, 3 steps, okay, and the mouse also from the bottom, right, uh, just 3 steps, okay. And if the mouse cuts by the cat, of course the mouse die, right? So, but if the mouse survives after 3 steps, the person will rescue the mouse. Okay. It's a simplified game. So now, yeah, can you develop the game matrix or possible strategies? So the answer is rather simple. Okay, so you have 2 players here. Okay, cat and a mouse. Okay, now cat has 8 strategies, and the mouse also have 8 strategies. So the game matrix will be 8 by 8. Okay, so these are the strategies for the cat. Okay, so you see can 3 turn, right? 1, 2, 3, and or this one or that one. So these are the all possible possible movement for the cat, and on the right hand side here, and all the possible movement for the mouse. And so these are the, let's name this strategy 1 to 8. That means now you can create this kind of game matrix, 8 by 8. So this is the 1, 2, 3 until 8 ada the name based on this earlier strategy 1 to strategy 8. Yeah. And then what is the meaning of 0? And what's the meaning of 1? Why there is no -1? What do you think? What's the meaning of 0? Meaning the mouse is rescued. Okay. So what is the meaning of 1? That 1 in here means the mouse was eaten by the cat. Okay. So because this is the payoff for cat, remember? The payoff matrix is for the row. So if 1 in here, that means the mouse is -1. The mouse died. Is it clear? So there is no winning for the mouse, so that's why there is no -1. Okay. Okay. So I hope this is clear enough. Okay, next. Now, okay, we already have the children. A while ago, Sai make the game matrix for rock, paper, scissors, right? So now let's modify, okay, this game. The rule will change. We will use the same cycle that seesaw is larger than paper and paper is larger than the rock. But, okay, if you win using seesaw, you will get 3 points. If you win using rock, you will get 2 points. And if you win using paper, you get 1 point. And if you lose or draw, you get 0 points. Okay. Can you create the game matrix for Miss Row and Mr. Kong? If we change a little bit the rule for rock, paper, scissors, game. Anyone? Just practice. Yes, Katrina. You can share your screen. I can stop this one.
Prof, it says host disabled participant screen sharing.
Oh, really? Wait. Oh, no, you can.
Okay.
So,
Basically, sir, the top one is the original rock, paper, scissors, and the one on the bottom is the modified. Basically, it says that if you lose, it's only 0. So I think the negative values should be converted to 0. And then those winning or positive values will be converted to their corresponding. Winning by paper is 1, for rock is 2, and scissors is 3.
okay. So,
Okay, I think Joven has a better
okay,
answer.
okay. This is for who? For the row. No? 0. Yeah, Joven, you want to say something? Okay.
Can you see my screen, sir?
Yes, yes.
So it's it's almost the same thought as Ma'am Katrina, but there should be two results, sir, the row versus the column, sir.
Yes.
So there is a comma. If there
Yeah.
is draw, for example, the two players are scissors, both of them got 0 points. So there's for the row 0, the column 0 for this part. Then for the second case, with the row is scissor, the paper is the second column, which is the second case, scissor versus paper. The row will get 3 points while the paper lost, so 0 points. Then for the last case, for the scissor or row 1, the scissor versus the rock, the scissor will lose, so 0 points for the row. Then if you win by the a rock, you will get 2
We'll
points.
get 2 points, yeah.
Then we can see, the diagonals are all zero since if
Yep.
they are draw,
And
both of them got
symmetric.
zero. Then it's almost what do you call this, identity matrix or
Symmetric. Yeah.
symmetric. Yes, symmetric.
Okay. So just the diagonal is the symmetric points.
Yes.
Okay. Very good, Chopin. Yeah. So when you have this is the introduction. Yeah, Chopin is correct. Okay. So now if you want to see, this is no longer zero-sum games. Okay. When you have no more zero-sum games, the number is no longer one, but two. Okay. One is for the row, and the other one is for the columns. So very good. Yeah. So I hope this is clear. Okay. Yeah. So this is what Chopin was showing a while ago. Now, now let's make a story. Yeah. So you can read. Yeah. Frank cannot remember that today is his. Frank is very old. Okay. So he cannot remember that today is his the birthday of his wife or not. Okay. And he goes home late. So everything is closed except for the florist. Yeah. If it is not her birthday and he bring no gift, it is okay. Right? So that means the payoff is zero. If it is not her birthday and he bring gift, she may get confused but happy. So +1. Okay. Now, if it is her birthday and he bring no gift, she may get upset. So let's say -10. Okay. Now, if it is her birthday and he brings only flower, she might be happier. So plus 1.5. Now, question is, can you make the K matrix for this situation? Practice. Yeah? So practice modeling. So you have the situation, can you just make a K matrix? So question, is this zero-sum game or non-zero-sum games? And can you create a K matrix? Yes, Chopin again. Go ahead. So I will stop my sharing. You can share your screen.
Here's my answer, sir.
Okay, so if no gift,
I mean, yes, birthday na lang.
okay.
So based from the given, sir, if it's it is or they is or celebrating the birthday, but he has no gift, we will get a -10. If it is you're celebrating the birthday, but you gave flowers as a gift, so yes, gift, will get 1.5.
Yes.
Then for the other case, says it's not your birthday, not gift, so there's
Zero.
nothing we will gain or lose. Then for the not birthday, then you provided gift, you will get
But
1. Yes.
for the others clear here. So this is how you can create that game matrix. Okay, very good job. Okay. So these are examples. All you can already know how to create game matrix. Yeah? You can create based on the path or based on the story. Right? You can also think this is zero-sum games or non-zero-sum games. Yeah? Clear? Okay. So with this, I will go to the next topics. It is more on the computation. Okay. Let's go to the solution. Okay. First one is zero-sum game first. Okay. Share my screen. Okay, so this is the next slide. You can also get this one. Model. Can you see the screen? So, in this course, you will learn about subtle point and then value of the game. Okay, and we will compute with different way. Okay. If you can find subtle point, then you do it. If you cannot, another technique is called domination. Okay. And some games you cannot find using subtle point and domination. Okay. This game is called mixed strategy. So I will show you some tricks, and then we can also do using linear programming in Excel. Okay. And at the end, I will show you about the scaling property of these games. Okay. Okay. So I hope you can see the screen. Okay. So this is the game of what is called zero-sum game. So we have only one numbers here. Okay. In the matrix. So for example, if row choose A and Mr. Column choose C, so Mr. Row will get 4. That means Mr. Column will lose 4. Okay, and so on. Now, the question is how Miss Row to select her strategy and how Mr. Column will select his strategy. Okay, remember the assumption is rational. Yeah, rational player. That means both player will try to play safe. So in that case, yeah, look at this. Okay. The solution is rather simple. Okay. You remember last time we discussed about minimax and maximum, right? So that's how you solve it. So for Miss Row, okay, Miss Row will find the minimum in each row. Okay, in each row, it will find the minimum. What's the meaning? That's meaning the worst payoff for each choice. Okay. After that, this row will select the maximum among the minima. So that means getting the best among the worst. Yeah. So the strategy for this row is always maximin. Yeah? The meaning of maximin is you get the argument of the max. Okay? First, you get the minimum for each row, and then you get the argument on the columns. Okay, so you get the minimum for across all columns, and then you get the argument which row that you will choose. Okay. Let's see example. Okay, so this is Miss Row. This is the payoff matrix, right? So then what you will do, you get the minimum in each row. So 6 and 5, 5. 5 and 4, 4 is the minimum, right? So that means if Miss Row select strategy A here, okay, Miss Row will get guarantee, okay, at least she will get 5. She will not get 4 if she choose A. Okay. How about Mr. Column? Mr. Column, because he actually, this payoff matrix is for Miss Row, that means he will get the negative of that, right? That means Mr. Column will find the maximum in each column. What's the meaning? Maximum means the worst payoff for each choice. Okay? And then find the minimum among these maxima. Yeah, that means again the same, yeah, the best among the worst. So the strategy of Mr. Column will be minimax the cost. Okay, so first you maximize and then you do minimum. Yeah? So this is the example. Okay, the same payoff matrix here. So between 5 and 4, what is the maximum? 5. Yeah? Between 6 and 5, what's the maximum? 6. Now between 6 and 5, which one is the minimum? So of course 5 again. Okay. So in this case, if Mr. Column select this strategy D, okay, it will be guaranteed, will never lose greater than this 5. Of course, he always want to hold smaller than 5. Okay. Yeah, we know that this is bad for Mr. Column because this is positive all. Okay. This 5 means negative actually for Mr. Column. Okay. So now we will call saddle point. We will call that solution is called saddle point when the larger of row minima is equal to the smaller of column maxima. That means if you can find maximin is equal to the minimax, okay, that is the saddle point value. Okay, so this saddle point value is called the game solution, okay, or we call it equilibrium. Okay, so if you can find this, not necessarily you can find, okay, if you can find this equilibrium, then okay, you can predict, okay, given the game matrix, you can predict, okay, what Mr. Row will do and what the Mr. Column will do. So the equilibrium is the solution, so you can predict already, okay, given the situation. Okay, now when the minimax equal to maximin, that saddle point, okay, the value in that saddle point is called the value of the games. Okay? So what's the meaning of value of the games? Okay? That means unless the opponent is actually playing poorly, on average, you cannot win more than the value of the game. Okay? When the value of the game is positive, okay, now the amount of that the row have to pay column in order to make the game fair. Okay? That is the value of the game. Okay? If this is negative, that means the row will always pay to the column. When the value of the game is 0, that game is fair for row and columns. Okay. So in our example a while ago, okay, so we see that minimax and maximum is exactly the same. Okay? So in this case, we got the center point, which is 5. This point is the equilibrium. Okay. So this means the center point of the game value is 5. Is this clear or not? Can you make it? Any question? Easy, right? So for each row, you get the minimum and then maximum. For each column, you get the at the bottom, okay, you get the maximum first, and then you get the minimum among the two columns. Okay. So these are the summary of the steps. Okay. First, you check the game matrix, okay? And then you get the minimum for each row, and then you just mark. And then again, you get the maximum for each column, you mark it. Now, if the intersection, okay, is actually in one cell and has the same value, then you get the saddle point. Okay. So again, saddle point is not always exists. Yeah? If it exists, then you get the value of the game. Equilibrium. Okay. Practice. Yeah? So, can you find the saddle point of this game? Yes, Marian. Marian. Yeah. I will stop this.
Can I share my screen?
Sure. I think you are already. Yeah, all the goals.
Can you see my screen, sir? Sorry.
Okay.
So
You get the minimum,
yes,
okay, 2 and minus 5, and then you get the maximum 4 and 2, and you get the maximum among the minimum and the minimum among the maximum, and that exactly the same. Yeah. So 2. So the value of the game is 2 in this case. Yeah. Very good.
thank you po.
Yes. How about the next practice? Oh, can anyone find the center point of this one? Can anyone get the center point of the oil company problem? Yes, Joby. I'll stop my sharing. Go. Minimum is 7, and
Hello,
then
sir.
it's 5. Okay, the maximum is minus 5, and then
So I
after
think
that,
there is no saddle point, sir.
correct. There is no saddle point. Yeah, this is the
There are
example.
difference.
Okay, why there is no saddle point?
Difference, sir, maximin and minimax.
Yes, the maximin and minimax is not the same. Okay, so there is no saddle point.
Yes.
Then you may ask, oh, if I cannot find saddle point, can I solve that? Yes, you can still solve that. Okay, so the game that has saddle point is called the game of pure strategy. Okay, the jargon, so that you pure strategy means without any probability, you can find. So if minimax equal to the maximin, okay, that is the game of pure strategy. That means you find the saddle point. But if you cannot find the saddle point, okay, that game is called mixed strategy. Okay, the game of mixed strategy, okay, for its alternative, okay, of each player, they have certain probability. What's the meaning of that probability? That probability means, okay, they will play not just one time, they will play many times, okay, and then from that many times of the play, okay, they get the probability distribution. Okay, so how many times, which one is higher in terms of probability? Okay, so of course, the higher probability will get a higher chance to win if you use that. Okay. Using that probability value on its column and row, okay, then you can find the game value again later. Yeah. So now another technique, okay, is to use what is called domination. Okay. So what is dominant strategy? Okay, I will share this screen. Okay. Can you see? Yeah. Dominant strategy is a strategy that gives you higher payoff than all. The keyword is all. Yeah. Than all of your other strategies, regardless what your opponent does. Okay. So if one strategy is superior to another for all the cells, either in column or in row, okay, that superior strategy is called dominant. Okay. Of course, because we are using zero-sum games, a row must maximize the value. So you will look for larger row values. For columns, it will minimize the value. So in the column, you look for smaller column values. Okay. Now, if domination exists, then that K matrix can be reduced. Okay. To show only dominance row and column. So domination technique is to reduce the K matrix. For example, you have very big K matrix, you can reduce it so that smaller. Okay, so let's take example in this game. Okay, so can you see? Okay, in each row, 4 is larger than 3, and then 2 is larger than -5, isn't it? Okay. So row A dominate row B. Okay. So in that case, I will delete row B. Okay, so no more row B. Okay. Now for columns, we want to minimize, right? So for column, we want to minimize. Okay. So in that case, now compare C and D. Okay. So which one is smaller? D is smaller than 2 is smaller than 4, and then -5 is smaller than 3. Yeah? So in that case, for all, right? For all rows, that means column D, okay, is superior compared to column C. In that case, you delete column C. Okay? Is it clear or not? Domination. For rows, you get the maximum for all. For columns, you get the minimum for all rows. And then, say, in this example, we can do both. Yeah? Domination by rows and domination by columns. So here, of course, row A dominated row B, so row B is no more. So I get this one. And then between C and D, D is dominated C. So in this case, I get the solution now because I get only one cell. So I already get the solution, yeah, with this AD. So you can compare with Minimax Maximin a while ago. You get exactly the same answer. Yes, Joven.
So is it always consistent that one row is always dominant?
No.
And for example, sir,
Domination is not always exist.
oh, I'm just thinking, sir, for example, in the for this example, sir, row A has 4, 2, while row B, for example, I change the -5 into 1.
Right.
So it's not,
Yes.
3. Sir, for example, 3. For the first row, for column C, for example, we're
It's
looking at column
dominated,
C.
right? So this one is not. So that means you cannot dominate by row. Then you go to the column. Is there any
Okay, sir.
possibility of dominated? So if both rows and column cannot be dominated, then you stop. You cannot use domination technique.
Okay, sir. Okay. Thank you,
Okay,
sir.
so this is just a technique to check if you can reduce the big matrix into smaller one. If you can get in this example, you can get up to one cell. That means you get the saddle points. Okay. Not necessarily you can get. And domination not always exists also. Okay. Yeah, good question, Jobin. Yeah. So, and this is the real story during World War II. Okay. This is called the Battle of Bismarck Sea. So this I got the map here. This is Papua New Guinea now. Okay. And in 1943, General Imamura want to transport Japanese troops across this Bismarck Sea, okay, to New Guinea. So, and General Kenny from the US want to bomb that troop transport. Okay, so But Imamura must choose between two routes in the north or south. Okay? North is shorter, okay, and then south is longer. Okay. While General Kinney must decide, okay, where to send his plane to look for this Japanese. Remember, this is 1943. Okay, the plane at that time, even the wheel cannot go up. Okay, still very low tech compared to today. Okay, so they need to get the correct guess. Okay, so if General Kinney sent his plane to the wrong route, okay, of course he can recall them, but the number of days of bombing will be reduced. Okay, so and look at what happened. Yeah, so these are the number of days. The payoff matrix represents the number of days for Kinney, and then on the column is General Imamura. Okay, better to use the north or the south. Okay? And these are the value, okay, for the first one is for Kenny and the second one for Imamura. But look at this game value. My question to you, is this zero-sum games or non-zero-sum game? Hmm? So I give you this Bell matrix, okay? Is this zero-sum game or non-zero-sum game? Okay. Initially, you may thought, oh, I have two numbers here. That means non-zero-sum game. But if you look at the sum, okay, 2 and minus 2, 2 and minus 2, 1 and minus 1, okay, 3 and minus 3. The sum of itself is actually 0, right? So this is actually zero-sum game. Okay, so the situation means Kenny always win anyway. Okay, clear? So now, can you find the solution of this game? Anyone? What you will do, first, can you find saddle point? If you cannot, can you try to do domination? Can you find the domination? Yes. Jovin, go ahead.
Hello, sir. I'll just try, sir.
You can try. Okay.
So I just get
Two,
since
two,
you call
two,
this
1, 3. That's correct. Okay.
since what do you call this? The left Kenny, what do you call that, sir?
Yeah, Kenny.
Since Kenny always win, I just get the raw values.
Mm-hmm.
And then I just use the minimax and maximin.
Mm-hmm.
So I got 2 and 2, so the saddle
So
point
that
is
is a
2.
saddle point.
So this is the common, sir.
So where is the result?
Here, sir.
Yes. So the result is north-north. Okay, General Kenny will send the plane to the north, and apparently General Imamura also sent the plane to the north. And that's what happened exactly during World War II. So this is historical record. Okay. Whoa. Okay. So amazing, right? So even at the time, this is already used by military war at that time. Okay, so we can also use domination. Okay, So first you can check if there is a row domination. Upon you cannot, and then try to find a column with domination. Then you can. Okay. Then you can reduce again by row domination, and then you can get exactly the same answer as a while ago. Okay. Okay. Next problem. Okay. This is a hard problem. Okay. The mouse and column games, cat and mouse games a while ago, 8 by 8. Okay. Can anyone solve that? The mouse and one. Yeah. The cat and mouse game. This is the game matrix a while ago, right? So well, you probably don't solve this, but can you just at least reduce the game matrix? So can you just reduce the game matrix by domination? Remember, if between rows, you get the maximum. Between columns, you get the minimum to dominate. Yeah. So between two rows, you look for two rows, okay? Which one is actually dominate for all columns? And then between two columns, which one is dominate for all rows? Like that. So the keyword is for all. One. Do you understand the meaning of domination? Can be equal, yeah? Okay, so say between two rows, okay, which one is e larger or equal? Between two
Prof,
columns.
should we
Yes.
total the rows and columns?
No, not the total. Be comparing itself for its, for example, between, okay, let's say example, yeah? Between 5, can you see that? Between 5 and 1. So can you see? Now between row 5 and row 1. Okay, so 0 and 0 the same. Yeah? 1 and 0, so 5 dominate, right? And then 1 and 0, so 5 again dominate. 1 and 1 the same, so 5 still dominate. 1 and 0, so 5 dominate. 1 and 0, again 5 dominate. 1 and 0 again, 5 dominate. 1 and 1, so 5 dominate. So in this case, row 1 I will delete. Clear? For columns, you find the minimum. Yeah. Smaller or equal for the
Can
column.
I share?
Yeah. Go.
I think I'm not sure if this is correct.
Okay.
Zero.
So which one is dominate?
I think, Prof, it's 4 and 5, row 4 and 5, and uh column 1 and 8,
Yes, but
because
okay, can you explain one by one? For example, how do you?
hmm. So I added the rows per row and then get the maximum, which are 4 and 5, row 4 and 5, and
Okay.
then added the columns and then get the minimum, which is
One.
column 1 and 8, and then I only chose the values from those.
Who are okay different.
Yes po.
Okay. Good. Yeah. Actually, you need to check one by one. Okay. But anyway, in this case, the value is rather simple between 0 and 1, so you can do this. Okay. Right. Thank you. Yeah. So right from first you have the game matrix, right? Of 8 by 8. Okay. After that, what you do is to find which strategy dominate for the card, and then you see that 5 dominate 1, 2, 3, 6, and 7. So you can compare between 5 and all these strategies, and then 4 also dominate number 8. Okay, so 4 and 8 you can compare. Okay, and then in that case, the one that dominated you can delete. And so we have only 4 and 5, and then from here you can delete the column. Okay, so find the column domination. Okay, with the same strategy. And so 1 in this case dominate 5, and then 8 is actually dominate 4. Okay. Well, the others are the same. Okay. So in that case, you can reduce like this. Okay, so only 1, 2, and 8. So and then now we can combine both columns and row. Okay. Then you get this reduce game matrix, and then from here you again find the domination. Okay. Finally, you get only this one. This is the most reduced matrix between cat and mouse a while ago. Okay. Okay, so if the game has no saddle point, okay, how are we going to find the solution of the game? So in that case, you introduce, okay, what is called probability. Okay? So we have a term now. So a game of pure strategy, earlier games, okay, that means you only play one time a game. Okay? But when you play the same game many times, okay, then you need grand strategy. So we call this mixed strategy. The element of mixed strategy is pure strategy. Okay, but now you have certain probability for that. Okay, so what is mixed strategy? It's a grand strategy which is to let the decision for each particular play is governed by chance and by probability. Okay, so in that case, you can find the R, okay, to be played for each strategy. Okay, so this is how you compute. Okay, a while ago, okay, this game of oil company, okay, you cannot find the central point, isn't it? So how I will find the R? Okay, look at this. This is the game. So you can put some kind of probability here. Okay, so I will put X for the trail and then 1 minus X, right? Because probability must be 1 in total. The same thing here. If no oil, I will just put notation Y. And then if it has oil, so 1 minus Y. So this is the probability. Okay. So I want to find out. Okay. So, or the probability, basically. So in this case, we can multiply. Okay. So this value minus 7 multiplied by the X. Okay. And then 1 here multiplied by 1 minus X. Okay. This must be equal to this one. Okay, 10 multiplied by this X minus 5 multiplied by 1 minus X. This is the equation. Okay, once you get this equation, you can solve algebraically. Okay, so I can get X equal to 6 over 23. Okay, now the same thing for the columns. Okay, so you can see minus 7 multiplied by the Y plus 10 multiplied by 1 minus Y. Okay, this must be equal to, okay, 1 multiplied by the Y, okay, minus 5 multiplied by 1 minus Y. Okay, so then from this equation, you can solve algebraically. You get this value. So you get X and Y. Of course, 1 minus X and 1 minus Y is just simple. Okay, is it clear or not? Okay, we just use algebra, okay, to solve this. Okay, so if you multiply this probability, this is 6 over 23 and 15 over 23. So the denominator is 23. So you multiply that. Okay, so you get the art. Okay, so these are the art, okay, of drilling and selling, no oil and oil. So by getting the art, so you know, okay, actually the equilibrium is in here, right? Sell and no oil. So this is the value. So the question is how I will get the game value. Okay. So once you know the art, okay, can we get the expected value for each row and each column? Okay. So in that case, you can calculate. Okay. So the art multiplied by the payoff. Yeah? For drill, can you see? For the drill, now you have minus 7 here, multiplied by 15. Okay. And then 8 multiplied by 10. Okay. So 8 multiplied by 10. So for the drill, either this is like the probability, right? So minus 7 multiplied by the art, and then 10, the payoff multiplied by the art again. So this is the value for drill. The same thing here. So 1 multiplied by 15, then minus 5 multiplied by 8. Okay. That is for the sell equipment. Of course, because this is art, so you must sum, yeah, of this art so that you can get back the probability anyway. So if your computation is correct, okay, if your computation is correct, so you will see for all players and for all alternative, you will get a constant. Yeah, this constant is minus 23 per minus 25 over 23, which is minus 1.086. Yeah. So what's the meaning of minus? Yeah? Minus mean unfair. Okay. Well, again, this is for the row, so that means this is unfair for the row for the oil company. Okay, so in this kind of game, okay, the oil company is always losing about $1 million. Yeah? Yeah. So whatever strategy to select, okay, that this company cannot win, okay, more than this game value. Up to here, is there any question? Is it clear or not?
Prof,
Yeah.
is it always 1 minus x and 1 minus y?
Oh, because we have only two values. Okay, but
what if it's 3 by 3?
oh, that is complicated. Okay, but I'll give you the trick how to compute later. Okay, but first, can you see, okay, how do you compute the uh, probability using algebra or using R? And then how do you get the value of the games? Of course, you can use solver also later, okay? If your game getting more complex. And solver in Excel or in Google spreadsheet. Okay, so now let's, instead of algebra, I will give you a trick. Okay, I'll give you a trick. Oh, okay. So before the trick, I will show you the Frank a while ago. Frank problem. The old man with the wife and sending the flower. Okay. We can also get the art from that. Okay. So, can we get the screen? As you can see, right? So this is the problem a while ago, okay? Right, and then what do we do? Okay. Now we can calculate the R. Okay, these are the R, okay, for Frank, and this is the R for the nature. Okay, then you ask me, how do you get this R? One way is to compute, okay, using that technique, okay, algebra. Okay, so the art is will be how much? If this is, because this is art, so you can multiply by scaling. So if this is 1, this become 24, right? So the art is Frank will buy flower, okay, and the art for the nature is not the birthday anyway. Okay? And then if you multiply all of this, okay, you will get the game value of 1.44. The real question is, how do you get this art? Okay? So remember this, yeah. When you have a game of mixed strategy, the average payoff is always the same when you can find the good mixture. Yeah? It is the probability or the or it's of the alternative. Okay. So if you cannot find a good mixture, okay, then you will see you cannot get the correct answer, okay, of exact the same. Okay. Now, okay, I'll give you a trick to compute very fast the art or the probability. Okay. So similar to high school before, probably the math teacher always give you trick how to compute. Right? So here also in game theory, there are some trick, okay, to compute fast without algebra. Okay. So this is based on rule of thumb. Okay. So in this example, what you will do? The technique is simple. Okay. Number one, you find the difference between row. Okay. And then, okay, make them positive, so you get the absolute value, and then reverse. That is for the columns. Okay, so in this example, okay, you minus between row, so -7 -1. This one is 10 minus -5, so it becomes 15. Okay, and then you reverse, put positive value, so 8 and 15, and then you reverse there. Okay, so then you can get. So the out of no oil and oil is 15 and 8. Okay? So reverse. This 15 going here, this 8 going there. Okay, the reverse. Take the difference between row, get the positive value, and then reverse. Clear? That is for the art for columns. The same if you want to get the art for rows. Okay, what happened? You need to find the difference between columns. Okay, so here -7 and -10, the difference, right? And then 1 minus -5, so you get 6. Okay, and then you get the positive value and then reverse. Okay, so become 6 for drill and then 17 for cell equity. Okay, so then exactly the answer a while ago. That one, right? 6, 17, 15, and 8. Is it clear or not? And this technique is only for 2 by 2. Okay, if you have 2 by 3, 3 by 3 is not, you cannot. Only for 2 by 2. Any question? Okay, let's practice. Okay, let's practice. First, you can practice this one, and then can you also practice for this one, front, pie flower, and then one more practice for this one. Okay. So 3% in the class. Please compute the art, okay, or the probability, and then the game value. Okay. For the oil, the flowers, and the last one. 3, 1, 2, 4. You can just choose one of the things, and then you show. Is the technique simple enough? Just take the difference, the absolute value, and then reverse. Yeah. Actually, you can do it by eyes. Okay. Yes. Sorry.
Can I try, sir,
Go.
for Mr.
Right. Okay. Go.
So for Mrs. Row, A and B, 3, 1, 2,
This
and
one is
4.
okay.
So from the example earlier, we get the difference and then absolute value and then reverse them.
Correct.
So the odds is 3:1.
Correct.
Then this one, same process, they have the same odds.
Okay. So either 2 and 2 or 1 and 1. It's the same. Right? And then what is the game value?
The game value, I'm not sure how to get it, Prof.
You multiply the art with the payoff. Okay. And then plus the other art multiplied by the payoff. Okay. And then divided by the sum of the art. So here example. Okay, can you go to 49, D49?
G49.
Yeah, so that one you multiply 3 with, say you want to get 8, right? So 3 multiplied by the 3 down 48, 46. Okay, and then plus, right? That one 1 multiplied by the up again down 1, correct? Okay, and then you put parenthesis. Okay, and then divide by the sum of the art, right? So in this case, 3 plus 1.
3,
No, the 3 at the bottom.
3
Yes,
plus 1.
Yes. So close it. So that's supposed to be the, okay, now that is for A. Okay, now you can get also for B and C and D. They are all must be the same. If not the same, George, something is wrong with your art. Okay. You want to get for B? That is for A, right? So how about for B?
It's the same, Prof.
Yes, but your computation is not correct.
This one?
Yes. Oh yeah, correct. That one. Okay, because you put star, yeah. Very good. And then how about for C and D? So on the right side, so you can okay, C and D. That now 2 multiplied by 3, right? For C that one, yeah. Plus
sorry, Prof.
Yeah. The art is 2 multiplied by 3, right? The payoff. The art multiplied by payoff, and then the other art multiplied by sum of the art multiplied by the payoff. So in this case, you have D42 multiplied by H42.
Times H42. Okay.
Okay. Plus.
So
yes, multiplied by, correct. And then again, you put a parenthesis. And then divided by the sum of the art. It is 2 plus 2. Yes, close it. You're supposed to get exact. So this means your computation is correct. Again, now you can also get for D. Yes, okay. So you can see for all the alternative, okay, when you get the correct art, okay, you will get exact game value. Okay. Which is 2.5 in this case. Clear, yeah?
thank you, Prof.
Yes, thank you. So, anyone else want to share screen? Maya, you want to show? Yes. How about the earlier thing for the front and the florist? So front bring flower on. So the one that Sai was doing, so Miss Ro had got the same art, 1 and 1, so it's 50-50 to choose between alternative A and B, right? But Mr. Column have art of 3 and 1. So in that case, of course, most probable, Mr. Column will choose C. Yes, Joven. Yes, Joven, you can share your screen. Okay, which one you want to show? Okay, so this is the
The
value.
oil
The oil company, yes.
Yes, sir.
So exact the same value, yeah.
Sir, yes. I just first get the difference of per row then per column.
And then record.
Then I'll get the odds by getting the absolute values and reversing it. So for the drill, the odds is 6 since
Yes.
reverse from the difference it's the cell equip, but in reverse it will be the drill.
Right.
Then the cell equipment, from the difference it's -17 from the row of drill. Since it reverse and absolute values it will be 17. Then I also did the step for the odds of the no oil and have oil. So I got the difference for the no oil -8 and the have oil
Right.
15. Then we will reverse an absolute
Right.
value for the
Absolute
no oil.
value. Yes.
Since it's in the column of the have oil, it will be the now the odd of the no oil. Absolute value is 15. Then for the have oil, we will get the difference of the column of the no oil, then get the absolute value. So it's 8. Then I will now get the game
Game
value.
value.
So they are all the same.
Oh, so that's very good. Yeah.
Yes.
So in this case, if you look at the art, okay, so which one is bigger art? So drill or cell equipment? Cell equipment is higher art, okay?
This one's are the maximum.
Yes, almost 3 times.
Yes.
Okay, and then the art of no oil is also bigger.
Yes. Sir.
Yes. So
This one.
if you do the same games again and again many times, okay, you probably want to sell equipment rather than trading. Okay. So unless the probability is really very big, so they don't want to do the trading. Okay. Very good. So anyone else want to show for the other game probably? Let's practice. Anyone? Okay, so if not, so I will continue. Okay, with 3 by 3. Again, this is a rule of thumb, so that means it's just a trick. Okay, why we have this trick so that when you see the game value, you can do it by hand actually. Okay, using your mind or using paper, you can actually do this. Okay, so this is supposed to be easy. Okay, so how to get the finding the arc, okay, of 3 by 3. Okay. You see? So the rule of thumb, yeah. So when I say rule of thumb, this is just a trick. So first, if you want to find the arc for the column, for one column, okay, you subtract its row from the preceding one. Okay, and then delete the column that you want to find the R. After that, okay, you do cross product of the matrix, okay, something like this, AD minus BC. Okay, so this other, and then this is the R is actually for that column. Okay. The same thing as give example. Okay, so say you want to find the R for strategy D. Okay, so what you will do, okay, you get the difference. Okay, this is again for 3 by 3 only. So that means A minus B and then B minus C. Is it clear? Okay. Now you want to find the R for D, right? So in that case, you remove D. Okay. And you see here, the one that you get the difference is 2, 6, minus 8, and minus 5. Okay, so this is the one that we copy here. Yeah. 2, 6, minus 8, minus 5. And then what you will do, this is A, B, C, D, and then cross. Okay, so 2 multiplied by minus 5 minus 6 multiplied by minus 8. And then take absolute value, so 38. So 38 is the R for D. Is it clear? Easy, yeah? Okay. Now, the same thing for, now you want to get the R for columns, okay? So you subtract each column from the preceding one, okay? And then delete the row that you want to find the R. And then again, the same technique, okay? Do the cross product of that matrix, yeah? AD minus BC. Yeah? So AD minus BC. Okay, so again, example. So here you want to find the R for strategy A. Okay, what you will do first, you find the difference. Okay, D minus E and then E minus F. Okay, so these are the difference, right? So you see here, okay, 6, 10, minus 2, 6, minus 6, minus 2, and 1. So suppose you want to find R for strategy A. So in this case, A you delete. Yeah, row A you delete. Okay, so what you have only 10 minus 2 minus 2 and 1. So there. Okay, and then from here you do AD minus BC. Okay, so 10 multiplied by 1 minus 2 multiplied by minus 2. So this is, and then you take absolute value. So anyway, this is already positive, so 6. So 6 is the R for the row that you delete. Yeah, that is A. Clear? Yes, Jobin.
Sir, why is there no absolute value for this?
And now this is because already positive anyway.
But in reality, sir, do we get the absolute?
Yeah, we need to get the absolute value.
The formula a while ago, sir, there's no
Yeah, the
absolute.
same, the same. This one is also with the absolute value.
Okay, sir.
Okay. Anyway, the art cannot be negative. Right.
Thank you,
So
sir.
always absolute value of this AD minus BC. Yeah. Is it clear? You want to practice? Okay. So again, I give you warning. Yeah. So this is just rule of thumb. Okay. Only for 2 by 2 and 3 by 3. Very nice method. Very fast. Okay. But okay, be careful. Yeah. It will give you false result if the game actually have saddle point. So be careful. I give you warning already. Okay. So that means you need to check if there is saddle point. If there is saddle point, don't use this rule of thumb. Okay. And then you check again using domination. Okay. Use algebra is complicated, so that's why you can use this rule of thumb. Okay. Domination is simple, right? So first you use a saddle point. Cannot find domination. Reduce first. Cannot find, then you use this rule of thumb. Okay. And if the game matrix is not 2 by 2, not 3 by 3, you cannot use this. Okay. You use how do you use? You use linear programming. Okay. Oh, okay. Can you find the solution of rock, scissors, paper game? 3 by 3. So what is the art? Oh, I think we have two type, yeah. The one with the anyway, this one first. The other one is non-zero sum. This one. What is the atom here? The art is
So is it 3?
hmm?
3? The odd?
3?
I'm not sure, sir. Negative 1. Negative 1.
111, right? Anyone want to share screen? For rock, scissors, paper, you cannot find any solution. Okay, so this is just to show that not all game have optimal solution. You know? Okay. Okay, so I want you to practice three person for the next one. I want you to practice 3 person to practice. This is just 2 by 2, so I hope you can make it. Okay, number 1. Okay, 8146. So what are the odds? And then number 2, 11479. What are the odds? And then number 3, 16 to 8, 12. What are the odds? Okay, can you make it? So 3%. So can you find the odds of 3 game payoff? Okay, so number 1 is 8146. Number 2 is 11479, and then number 3 is 16 to 8, 12. Can you get up? So this is easy because just 2 by 2. Sorry, you remember? Take the difference, take absolute value, and reverse. Super easy. So, should I assign or you volunteer? Come on. The first one, who will do? First one is 16 to 8, 12. Anyone? Who did not recite today? Oh, let's see. Paulo. And what else? Okay, so Katrina and Marian later. So today, please make a recitation. Yeah, so which one you want to show? 16 to 8, 12.
This one, sir.
You do the
11479.
11479.
Yes, sir.
Okay,
Use
2754. That's correct. Okay. Okay. So now, can you also make the others? Can you make the others?
What are the other? I'll just copy paste these, sir.
Okay, you can copy paste there also.
What's the other number, sir?
Okay, number 1, 16 to 8, 12.
2, 8, 12.
And then the second one, 8146.
I'll just do the rest. I'll just let
Okay,
them see.
so correct. So can you see the art is actually the same? The 3 of them. The art is actually the same for the 3 of them. So is that oh notice now?
I just need to get the lowest terms, sir, of the 16 to 8
Yeah.
and 12.
Right. So question is, the art are all equal. So is that by accident? So I put that the art is art. Why? I have 3 different payoff matrix. Okay? But the odds are equal. Interesting, isn't it? What is the pattern?
Sir, when one change, all the contents of the other matrix should change, sir, by a common factor or number,
Yes.
sir.
So this is what is the meaning of scaling. Okay? But because these are all utility, so when you plus with certain number positive, yeah, plus 3, yeah, and then multiply by 2, right? So it doesn't change the art. Yes, the game value changes, but the art does not change. Is that clear or not? This is the properties of game theory. You can add with any constant, or you can multiply with any constant, positive, no? Positive constant. Okay. The alternative that you will choose, the art is the same. That means the alternative that they will choose. Now, all the players will not change. So the actual value does not really matter. This is the main point. The matter is actually the order, because they are utilities, not the actual value that you need to get. Is that clear? Okay. So
Sir, I would like to clarify my answer related to the rock, paper,
okay, go.
scissors, sir. Since I'm getting 3, sir. Here, sir. Or do I need
Okay.
to lowest term? I need
This
to
one
divide.
is paper, rock, scissors, paper.
Yes, sir. Yes, sir. Then I did the this one, sir.
Yeah,
I
the
did
art is
the
the same. Right?
yes, sir. But I heard your answer, sir. So I need to divide this all by 3, sir. That's why.
Yeah. The art is the same. That means 111.
Okay, sir. So it's not wrong, sir. I thought I was
It's
wrong,
not
sir.
wrong. It's not wrong. Yeah.
Okay, sir.
Remember, art is any number because they are actually in comparison with the other. So you can divide by 3. They will
Okay,
get the same art anyway. Right?
yes, sir. Then, thank you, sir.
So correct. So
Thank you,
this
sir.
is correct. Okay. So eventually you will get this art multiplied by the same number, and then you divide, right? With the
Yes,
sum
sir.
of the art.
The
So in that
common
case,
denominators.
yes. So again, yeah, when you see game value also, not the game value, the payoff matrix, you can also multiply, you can also add, okay, with any constant.
Okay,
Yeah,
sir.
that is the behavior of the scaling. Okay, I hope this is clear enough.
Yes, sir.
Okay. And while the play is actually unaffected by the scaling, okay, meaning which one you will choose the alternative, but the game value will be affected, of course, right? So because the payoff is bigger, so then you will get bigger or smaller, right, depending on the same scaling. Okay. I will show you in the. So can you see? So when you use the 3 of them, okay, this one, right? The art is exactly the same. Okay. And this is actually, you can just add with 3, okay, and multiply by 2. So they are actually the same scalable payoff matrix. Okay, so you can add or multiply as long as do it for all. Okay, and then while the play is not affected by the scaling, okay, but now the game value will be exactly the same. Yeah? a while ago we add the 3 and multiply by 2. So that is exactly what happened. Also with the game value. Okay. So as a conclusion, okay, adding a constant to the payoff, okay, is just affect the unfairness level of the game. Okay, multiplying the payoff with the positive constant is actually just equivalent to change of the currency. Okay, so it will not change the alternative that you choose. Okay, so you can also try this game if you want. So if I toss a coin and you will guess the coin. If it is head, you guess tail. I will give you $10. If it is tail and you guess head, I will give you $30. If we are matched, you give me $20. So the question is, will you play this game with me many times, and why? Yes or no, and why? Can you create the schematics and the art? Okay.
Prof, just an
Yes.
initial thought. I think I can play it multiple times by guessing head always.
Okay. So
Because
because
if we're different, if it's tail and I guess head, I get $30. But if we match same head, it's the net is just $10. So I still have something to gain.
okay. So try to make the game matrix and compute the art.
Okay.
Okay. And then can you also compute the game value? Okay. So yes, you will. This game is unfair game. Okay, but unfair to whom? Right. So um, unfair to you or unfair to me? So please compute. Can you make it? Can you make the game matrix? And then, anyway, this is just 2 by 2. So we just take the difference, take absolute value, and then reverse to get the art. So this is zero-sum game. So okay, okay, cool.
This one, sir.
Where? Hold on.
Sir, I did not get the I knew that the game value will always be
Yeah, it will always the same here.
one.
So
But this is my row. It is me, my heads.
they had and tail and tail
So
20,
this the U,
20 minus, yeah.
the
This is
column.
minus 20, oh.
Sir, this is me,
Hi,
sir.
okay, this is okay.
Reverse, sir.
Reverse, reverse. Okay, so
Yes, sir. So for me, sir, I always get a positive game value of
yeah, okay.
1.25. So,
So
of course, I'm thinking of myself. So I want this positive.
okay,
So if it's positive, I always win, sir. It's been a win for
right,
me, sir. Unfair for you.
correct. Okay. Okay, good. So yeah, so you can get this game easily. Okay. Uh, Now the next question is, what if your game is not 2 by 2, is not 3 by 3, okay, but for any size, okay? So how are you going to find the solution of zero-sum game? Okay, the technique is using solver. Okay, so I will show you how to do that. Okay, let me get the okay, you see, yeah, this is the answer a while ago. Now, for the general solution, say if your game matrix is larger than 3 by 3 or 2 by 3 or 3 by 2 and so on, so you can use solver, Excel solver, use linear programming. So, of course, you will set probability to any values, okay, and then the sum of row probability will be 1, okay, the sum of column probability will be 1, okay, and then to get the value. Okay, so you get the value of each row and then each column. Okay, that means the payoff multiplied by probability, and then you can use solver to make the difference between minimax and maximin 0. Okay? So here is how to do. Okay, first you multiply the probability with the payoff. I know you don't know the probability, but you can set any value first there. Probability, okay, for the probability of each row and the probability of each column also, okay, and then you calculate the minimax and the maximum, right? And then you take the difference. This must be 0. This is the objective, okay. So what do you want to do? You want to get the probabilities of the rows, and this is the one that changed by the solver. What is the constraint? The of each of these probabilities, the sum must be 1 or between 0 and 1. Okay. So be careful when you use solver in Excel or in any spreadsheet. Why? Because the algorithm behind is actually numerical. Okay. this can be trapped into local optima. So in that case, initial values of the probability matter. So then you can select various values or change different values for initial values, and then get what is the most often values that happen. So you do several times, then you get the actual probability. Okay, so let's do for our examples. Okay, the one that we do oil a while ago. So I know we can do it using art and so on, but at least for the sake of argument, so that you know how to do. Okay, so input this value in the new sheet. Okay, and then you can calculate the minimax and maximin. And then initially you can set any probability. Yeah. In Excel, you can in here, because we have only two, so this one is 1 minus this probability, and then this one is also 1 minus this probability, right? Okay, and then this value is the probability multiplied by the sum of this. Yeah, so this one 7 multiplied by this probability, and then 10 multiplied by this probability is this given value. Okay? The same thing here. Yeah? 1 multiplied by this probability plus this one minus 5 multiplied by this probability is equal to this value on the right. SURP equipment. Okay? The same thing down. Okay? This value here is the same as this probability multiplied by minus 7, and this probability multiplied by 1. Okay? And here, this probability in column E is 10 multiplied by this probability and plus minus 5 multiplied by this probability. Initially, you can set, for example, 0 or 1 is up to you, and then it will compute it by the solver. Okay, so the objective value here, we can set the difference between these two values, and then the difference between these two values, and then you can take absolute value. Okay. Of course, our goal is to create this objective value to be 0. Okay. Is it clear or not? And show you the Excel. And so the Excel, we can set this one. You can set, for example, initially 0. Okay, here also you can set initially 0. And so of course, if this is 0, this must be 100, right? 1 minus. Okay, can you see my Excel? And then you use solver. Okay? This is the objective, is the absolute difference, sum of absolute difference between these two values and these two values. Okay, and then what you will do, we go to options here. Okay, go to plugins and get the solver. Solver is solver plugins, and clicks OK. Okay, we'll get the solver installed. Once you get the solver installed, okay, you can go to the data tab to see the solver there and set up. Okay, so here you can see the solver data tab. And I already set up. So here is the objective is J here J11, right? And then you set up the value to be 0. This is the target. So, and then by changing what probability, yeah? The probability is 2, the one that I put here, and this one, right? So because we have set that the probability is 1 minus the other one, so I don't need to put any constraint. So in this case, just solve. Oops, what happened? I make a mistake. The probabilities. Oh no, this one must be this one. Right, and then changing is this one, comma, this one. Okay, and then solve. It will solve. One of solution. Oh, I got that. Okay, so 66 and 23%. Okay, for this solution. And the result is this. For the drilling, it's the same thing. So you can set up any values and use the same technique. Please try, and then you can share your screen so that I will know that you already know how to compute this. For the exam, you know how to compute. So just in case you have a 3 by 3, okay, the same technique. Yeah? So, but now the probability is now 3, and then you can set up the constraint that the sum or the probability must be 0 and 1. So constraint, you can add the constraint. The same thing if you have 4 by 4, so you just set up all the probability must be between 0 and 1. Let's try 2 by 2 first, so that if you know this, I can the others is the same. Yes. And if you have difficulty, you share your screen. We can also discuss.
Prof, I think I haven't fully gotten how to calculate the game value.
Okay, you share your screen, I will help you.
But I think I've set up everything else.
Okay, so this is the oil drilling. Yeah? So first you set up the probability. Can I see this 0 point? Okay, and that one is 1 minus. Okay, good. That one is okay, 1 minus. Okay, now get the value first. Okay, the value is okay, so equal. Okay, so the probability J4 okay, multiply by -7, this one D4 yep, plus J5 plus plus J5 in your case. The second probability, the R2 probability, multiply by R2C1 probability. Can you see? Yeah, yes. Okay. That one is supposed to be the same value. Okay. Enter. Oh,
Sum of
no need because the sum is 1.
Okay. I see.
Okay.
Okay. So as is.
Yeah, because this is not R, this is probability already. No problem. So the same. Now you put copy, okay, but the probability you put dollar. The column J, there you put dollar. So that you column, yes. So you can copy to the right. Okay, not the same, right? No problem. Now the same thing in column K, K4, you do the same. Yeah. But now the probability down there multiply by -7 plus okay, the probability down there 0.6 multiplied by 10. Yeah. Okay, enter and then copy the same down. For probability, you put dollar, which is 10 and 10. Yeah, enter. Okay, copy. Okay, now the objective is to get the absolute value with of this one. D11 minus E11. Yes, and then the other one also, yeah. K4 and minus K5. Okay, good. So now you get to go to the solver. Do you have solver already? Not yet. Okay, go to the no, not close it. Solver. File. Can you go to file? Okay, down there option. Yep, add-ins. Add-ins, and then go at the bottom. Go. And select the oh, not the ideal flow, the add-ins of solver. Do you have a solver? Why
Oh,
not you? Why not?
previously, I think I was using Google Sheets for Solver, but I think I
Yeah.
understand the scenario.
Okay.
I will try it with Google Sheets again.
Okay, so you can use Google Sheet. You can save this and then open it in Google Sheet. You can use the solver in Google Sheet.
Okay.
Okay. The solver is easy. Just to get the objective value to be 0. Okay, by changing these two probability with this J4 and D10 in your case. Yes, that is the one that you will change. Okay. Okay, I hope this is clear now. Okay. Anyone want to ask question? Okay. So I can give you kind of summary. No? So what happened if your opponent, say after you put the games, okay, what if your opponent actually did not play the game rationally? So this is called poor play. Okay? Now, if the opponent did not play according to the rational choice, okay. Now, if the saddle point actually exists, you will always guarantee to get better than the value of the game, even in one game. Yeah? But if the saddle point does not exist, that means your game is mixed strategy. That means in the long run, if you play the game repeatedly, okay, you will always and if you select always the optimum strategy, okay, that means your average speed of winning is always better than the value of the game. So the value of the game actually guarantee you something. Okay. even though your opponent did not play rationally. So these are the summary. Okay? So zero-sum game is strictly competitive games, right? The equilibrium in the saddle point is when the maximum equal to the minimax. Okay. Now in zero-sum game, even if you inform your strategy to your opponent before you play, you will not get any advantage or disadvantage. Okay, you cannot make a threat in zero-sum games. Information doesn't matter. Okay, and so if you do a joint plan of action or communication prior to the game, also have no benefit at all. These are the properties of zero-sum game. Yeah? So this is the summary. So, you find the saddle point. If not exists, use domination. If not exists, use the mixed strategy, use the linear of programming or the up a while ago. Okay. So let's go to the next topic. It is actually more useful, which is called non-zero-sum game. So this is the one that you played last week. Okay, we'll close this one. So, okay, let's see what happened to non-zero-sum game. At the end, okay, you will have this homework. Okay, so the homework is about this traffic, this one, and the second one. Can you see? This is the homework later. Okay. So let's discuss this then one by one. Let's start from the beginning. Okay, so non-zero sum game. Okay, so in this lesson, you will learn again using first technique is using iterative domination. Okay? And then I will introduce you to more jargon, yeah, or terminology. First is Pareto optimal. Second is Nash equilibrium. Okay, so I checked this in the AI. I also give you the link to the AI so that you can see the explanation of AI is a little bit more complicated than this slide. Okay, more mathematical. Remember, okay, the one that we are discussing is called strategic game. Okay, so this is non-cooperative. Maybe next week we'll discuss cooperative games. Okay? So non-cooperative game can be competitive. So there is a conflict between agents. So the positive payoff of one player can means negative payoff of the other player, but not necessarily equal payoff. Yeah? So this is the zero-sum games a while ago is also a competitive game. Right? So if you see this in zero-sum game, you have only one numbers. That means the payoff of row, okay, is the same as negative payoff for the column. Okay. Now this is the one that we just discussed a while ago. But if you have non-zero-sum games, okay, now you have two numbers because you have two players, so you have two numbers. The first number is for the row, the second number is for the column. Okay? You see? Okay. So in this example, okay, so if if Miss Row play A and Mr. Column play F, then Miss Row will get 2, Mr. Column will get 1. If Miss Row play C and Mr. Column play F, okay, Miss Row lose 1, Mr. Column win 1. Clear, yeah? The meaning of this payoff matrix. The first number is for the column, for the row, and the second number is for the column. Okay. Now, a while ago, Kenny and Imamura came. Okay. You can also put zero-sum games into non-zero-sum format. Okay? But look at this, the sum of the cell will become 0. Okay, so that is how you determine this is actually zero-sum game or not. Okay, so in that case, non-zero-sum game is actually more general than zero-sum game. Yeah. Okay, so now these are the properties of non-zero-sum games. Okay, it's not strictly competitive, meaning sometimes you can cooperate. Yeah, and the equilibrium is not the same as maximin, is not the same as minimax in general. Okay, and if you inform your strategy to your opponent before you play, there is possibility that you may gain advantage or disadvantage. So this is more general. And if joint plan of action or communication prior of the games may have some benefit. Can you see the difference? Yeah? Zero-sum game and non-zero-sum game. So this is more interesting. Okay. Now, how you find the solution? Okay. The technique is rather simple. Okay. You look for the other point of view by doing this. Okay. You keep switching back and forth between your point of view and your opponent point of view, and then come back to your point of view, and then come back to your opponent point of view until you can get the actual solution. Okay, so by doing so, you actually practice to view yourself in other person's shoes, isn't it? Okay, so we will use two techniques. Okay, first is called iterative domination. Okay, this is the same as earlier. So we reduce the game matrix, the size. Okay, or we can use also Nash equilibrium. Okay, you can search in Google "Beautiful Mind." This is the name of movie. Okay, so that movie is talking about John Nash. Yeah? John Nash win a Nobel Prize, okay, in game theory. Look at this. This is so important, okay, that there are several Nobel Prize winner in game theory alone. Can you see that how important this game theory is in our daily life and also in economy, yeah, in transportation as well. Okay, in fact, okay, if you look at transportation point of view, okay, that is what is called Waltrop Principle 1, right? That is exactly Nash equilibrium. Okay, so let's discuss what is Nash equilibrium in a few moments. Okay, look at this. When we say domination, okay, can be strict or weak. Yeah, strict mean larger than or without equal. Okay? Weak mean there is equality. Equilibrium can be strict or weak. Okay? Look at this. When you have strict domination, you will get unique equilibrium. When you have weak domination, you will not get unique equilibrium usually. Okay. Let's see with the definition first, and then I will give you example. Okay. Dominant strategy, okay, is a strategy that give you higher payoff than all of your other strategies, regardless what your opponent does. Okay, so don't do strictly stupid strategy. What is that strictly stupid strategy? It's a strategy that gives you lower payoff than at least one of your other strategies, regardless of what your opponent does. Okay. So always try to play dominant strategy if you can find, but don't do this strictly stupid strategy. Okay, so here it is, the algorithm, okay, the technique, the steps. So take turn to be at each player's shoes until you can find a single set. Okay, first you play as row, right? So look, because you are playing as row, then what you will do, you look at the first number in any of the two rows. Okay, now if the payoff of one row is always larger than the other row, then the larger row dominates the smaller row. Okay, if domination is found, delete the dominated row, like a while ago. After that, okay, you play as column. Okay? Column, you look at the second number, right? Okay, in any of two columns, compare. Okay, now if the payoff of one column is always larger than, okay, there is no smaller than in here because the two of them are gain. So if larger than the other column, then larger column dominate the smaller column. Again, if domination is found, you delete the dominated column. Okay. If this is still not clear, let's see the example. Okay. Okay, let's see the example. This is non-zero sum games. I have a payoff matrix like this. Okay. So let us play first as Miss Row. Okay. So let's compare B and C and then A and B. Okay. So if we look at the B and C, look at this 2 compared to 1. B is winning. 1 compared to 0. B is winning. 0 compared to -1. Oh, B again winning. So in this case, row C is dominated. So you can delete row C. Okay. Why? Because row C is a very stupid strategy. So you never use this. Right? Okay. And then now you compare A and B. 1 and 2. Oh, B is winning. 0 and 1. Oh, B is winning again. But in here, 2 and 0. Oh, B is not winning. So in that case, you cannot select between A and B. Okay, I already deleted C. Okay, so now let's play as Mr. Column. Okay, so I already deleted C. Okay, now when you play as Mr. Column, you look for second number. Okay, so look at the second number and then you compare between column. Okay, so 1 and 2, and then 2 and 1 you cannot. Okay. And how about this one? 2 and 1, 1 and 0. Oh, we can dominate it, F, right? So in that case, F is deleted. Okay. Now I have this uh, game matrix which already reduced. Okay. I can play again, check between A and B. Okay. 2 minus when 1 and then 1 and 0. Oh, dominate now. Okay. A is deleted, isn't it? Okay, A is deleted, so I get only B. Now now I can compare between column D and E. 2 is larger than 1, right? The second number. So in this case, E is deleted. So I get the solution. Yeah, it is B and D. Clear or not? You want to practice so that we can get it? If you can find single cell, so you get the equilibrium. Yeah. That's exactly the last equilibrium. Then you may ask, what if I cannot find that single cell? Well, you can later. I will show you how to compute mass equilibrium. Okay. Okay, let's practice the game that we play last week, yeah, which is called prisoner dilemma. Okay, so I hope you still remember. Okay. This one, okay. So this is the prisoner dilemma game. Last week we played this several rounds. Okay, so the story. Yeah. So on prisoner dilemma, okay, two prisoners, Mr. Row and Mr. Column, being interrogated separately. Okay, if both confess, each is sentenced 8 years in prison. Yeah. Okay, -8, -8. Okay. If both deny their involvement, it's will sentence just 1 year. This one -1, -1. Okay. If just one is confessed, okay, is released, so 0. Okay. But the other prisoner will sentenced to 10 years. Okay. So can you get the combination? Yes, Jobin.
Or do I need to do the Excel, or we can do it but just by looking at the numbers?
You can also, if you can,
So since the confess, I will start, sir, with the row. All the
okay.
numbers in the row of confess is always larger than deny. So I will delete the deny. Then I will move to the column. The remaining is negative, 0, -10, then -8, -8. Then I will look at the two, second numbers of both column. -8 is always larger than -7. -7, so I will retain the confess.
Yes.
So in the end, confess. Yeah.
Confess,
Both of them.
confess. Very good. So by okay. So the design of the game is for you to confess. That means to betray each other. Okay. That's why last week, that's exactly what you behave, isn't it? Yeah. In the game last week when we play, okay, that's exactly what you behave. So why? Because the design of the game, okay, even though you are rational, okay, you try to play different way, okay, eventually the equilibrium will show the result. Okay, so confess. Okay, so right. So if you have this, okay, actually we can also put prisoner dilemma into more abstract. Yeah? The value is not necessarily that number, right? So you can put any number, okay, with certain condition like this. Yeah? This is the condition of prisoner dilemma. So we can put 4 values. Yeah. So we call it TRPS. Yeah? T mean temptation, attempted reward. R mean the report, okay, cooperation reward. P mean the punishment, betrayal punishment, and S is the second, yeah, deceived punishment. So with that, you can set up any value for prisoner dilemma games. Yeah? And you can also normalize this so that the cooperate will become 1 and 1, and then the minimum becomes 0 and 0. So, and then defect will be T and S in this case. So, this is what Joben was explaining a while ago. Yeah? If you can see this, so you can eventually get the confess. Yeah. Okay. So now I want to introduce you another terminology called Pareto optimality. Okay? So an outcome of a game is called Pareto optimal if there is no outcomes make every player at least as well off, or and at least a player is strictly better off. What is the meaning? Yeah, that you cannot improve without hurting at least one other player. So Pareto optimal is the welfare system of the society. Yeah. Okay. So in our game, how to get? You just simple compute the sum. Okay. The sum of the total payoff and then get the maximum. Yeah. So in our prisoner dilemma, okay, this is the sum is 1 minus 1 minus 1 is minus 2. Okay, this one minus 10 and minus 16, right? Of course, the best is minus 2. So in this case, Pareto optimal is T99, okay, but the equilibrium is convex. So the Pareto optimality for the society is this one, but the equilibrium, the one that you behave, is actually convex, or betraying each other. So it's not Pareto optimal in this case. Yeah, this is the design of the game is like that. Okay, so now can you find the equilibrium of this game, and can you also find the Pareto optimality? Anyone? Pareto optimal is easy, it's just sum. Okay? So it's clear. Which one is the largest? Okay, let's practice. This one more for domination, yeah, and Pareto optimality. You can share your screen once you, or you can explain. Yeah. Can you check the in row? Is there any dominant strategy? No, right? So if no, you check the columns. Is there any dominant strategy? And then delete the column that dominated. Come on, try. Yes, okay. You want to share the screen? Yes. Did you find the solution? Okay. So the equilibrium is okay, low. Yeah,
Sir, for the iterative domination, sir, it's low, sir. First, I deleted first the high because at the row there's no dominant.
correct.
This then I move to column, which is this H or the high is always dominated by both
Yep.
low and medium. Then this deleted. Then I returned to row. Uh, Remaining is low, medium. So back to the first numbers, 50 versus 40, then 30 versus 25. Medium is always dominated by low, so I deleted the medium.
Right.
Then I go back again to the column. Second number, 7 is dominated by 5, so
By five.
low. This is the answer for iterative
Correct.
domination.
So
But
5.
in
Low.
Yes, sir. But in the sum, the what do you call that?
The Pareto optimality.
Pareto optimal, sir. It's just 57. But if we gonna follow the Pareto optimal, this is the medium.
That is the largest, right?
This one, sir,
Medium is the largest. Correct. So the result is not Pareto optimal also. Okay. Low is actually the equilibrium.
Yes.
Okay. So equilibrium means you can predict, okay, if you play these games, okay, people will play low and low.
Yes.
Okay. And even though for the welfare, for both player, actually medium will be the best. Okay. They don't play the best. Okay. Now I want to introduce you, okay, the main part here is called Nash equilibrium. Okay. And in traffic, this is water principle one or the selfish equilibrium. Okay. That means everyone when they go to the road, they cannot choose any other route. They cannot choose any other route. So that's exactly Nash equilibrium. Okay. So here it is. You see? So Nash equilibrium is a state of the game where no player prefer different action if the current action of the other player are fixed. Okay, so it is a strategic combination by definition, and it's a strategic combination that means between the two players or many players. Okay, if so, it is called Nash equilibrium if no player have incentive to deviate from his strategy, given that the other player does not deviate. Okay, so sounds complicated. Yeah, so don't worry. Yeah? So the technique is simple. Okay, first you propose a strategic combination as if pretend that one of the player move first. It's not simultaneously. So play as if one of the player move first, then test, okay, whether each of these player strategy is the best response to the other strategies on. Okay, I'll give you example, okay, and then I'll give you the technique. Simple, yeah. Okay, the algorithm is rather simple. Okay, assume that row will play first. Okay, so assume that the row will play first. Okay, yeah. So, and now for each strategy of the row, okay, yeah, given this strategy is chosen by the row, what column will choose? Okay, so the column will select the best strategy for column, isn't it? So list this as list one. Okay, and then assume again the column will play first. Okay, now for each strategy of the column, given this strategy is chosen by the column, okay, the row will select the best strategy for row. Okay, this is called list two. So you create list one, list two. And then what you will do, find the intersection between these two lists. Okay, that is the Nash equilibrium. Okay. Okay. So I just want to add, okay, that sometimes we can find superior Nash equilibrium, sometimes not. So when you can find the best of the best, okay, that is called superior. Okay, for each row and each column. Okay, let's see by example so that we can see better. Okay, this is a story first. Okay, so there is a conflict between a man who want to go to a soccer games and a woman who want to go to a ballet. Okay, so while they are selfish, they are also deeply in love and would, if necessary, sacrifice their preference to be with each other. Okay, so top and bottom for Miss Row and left and right for uh, Mr. Column. Okay, so this top is probably what good for Miss Row. That means ballet. Okay? The bottom is the soccer. Okay? The same here. The right is soccer, and this is the ballet. Okay, so how to find the Nash equilibrium? Okay, so look at this. Okay. Now you play, let us play first as Miss Row. Okay. So when you look at when you play as Miss Row, okay, check the domination first, right? You check the domination first. Oh, this is 2 compared to 0, but this is 0 compared to 1. So no domination of the row. So you cannot use domination. And then what you will do, let's check the domination of the column. Yeah? Look at the second number also. 1 and 0, 0 and 2. So you can also find domination for the column. Unfortunately, you cannot use iterative domination in this game, right? So in that case, let's do Nash equilibrium. This is another technique, yeah? So let's assume first, Miss Row will play first, not simultaneously, but Miss Row will play first. So we can play as this diagrams, the 3 diagrams, or you can check directly in the payoff matrix. Yeah? Look at this. Now, what happens if Miss Row will play top? Okay, Miss Row will select top. Okay, Mr. Column knows. Okay, suppose pretending, yeah, that Mr. Column knows that Miss Row will play top. So what Mr. Column will do? Okay, yeah, 1 and 0, isn't it? So Mr. Column will choose this one, 1, because 1 is bigger than 0, isn't it? So in that case, the combination is TL, yeah, top left. Yeah? So I will put here. Now, next one. What if Miss Row will play bottom? What Mr. Column will do? Comparing between 0 and 2, isn't it? Right? So, of course, 2 is bigger than 0. So, Mr. Column will play right. If Mr. Row play bottom, Mr. Column will play right. So, in this case, bottom right. So, these are the lists. Yeah? So, because we set the Miss Row fixed, so in this case, list 1. Okay. Now, if you look at this TL and PR, okay. Okay. Now, suppose Miss Row must between these two, which one Miss Row will choose? between TL and BR. Of course, between 2 and 1, right? Miss Rowe will choose this one. So that means TL is superior. Okay, TL is superior. Next. Now, let's assume Mr. Column will play first, not Miss Rowe. Now assume Mr. Column play first. Okay, we reverse the three diagrams. Okay, so what we will do? Suppose, okay, Mr. Column play left. Okay, if Mr. Column play first left, what will happen? What Miss Rowe will do? Miss Rowe will compare between 2 and 0, isn't it? Of course, Miss Rowe will choose 2. Okay, so again, be careful in the list. You still need to put it as row column. So in this case, still TL. Okay, now what happened if Mr. Column decided to choose right here? So what Miss Rowe will do? Miss Rowe will compare between 0 and 1. Of course, Miss Rowe will choose B. Yeah, with this one here, bigger, right, than 0. So the choice is BR again. Oh, so the intersection is what? TL and BR. Yeah, we have list 2 is TL and BR. Between list 1 and list 2, the intersection is TL and BR. Yeah. If Mr. Column should choose between TL and BR, what Mr. Column will choose? Mr. Column will choose between 1 and 2. Of course, Mr. Column will choose BR, right? This is the superior NAS for Mr. Column. Okay. So in that case, you have two superior NAS. Yeah. One is for Miss Rowe, this one, and the other one is for Mr. Column. Remember this, yeah. NAS equilibrium not always exists. Yeah. When it exists, it is not always unique. So in this is the example that you have two NAS equilibrium. Okay. Look at this now. Okay. If you face this kind of situation, okay, what you will do? What is the trick so that you will win? Okay. So the trick is simple. Okay. This is called disclosing strategy. Yeah. In this battle of sexes, you have two NAS equilibrium. When you have more than one NAS equilibrium, okay, then probably you test first. Yeah? What will happen if actually you announce first? So, okay, those who has reputation of inflexibility and disclose first will actually gain the advantage. Yeah? So you just say, I'm going to do this. Yeah? Make up your mind and do what you want. Okay, up to you. Okay, so in that case, okay, say if Miss Rowe said first, so Mr. Column will choose whatever Miss Rowe will get into that equilibrium. Yeah. Okay. So if no pre-play communication and the player can select simultaneously, so it may end up in the non-equilibrium. So this is what will happen. Yeah. So NAS equilibrium not always exists. Yeah. So if the NAS equilibrium don't exist, you cannot predict. Okay. If exists uniquely, so you can predict exactly what is going to happen. Okay. If more than one, so probably you can test. Okay. The power of disclosing. I will move first, okay, or I will move later. And that's probably one of the. So this is other variants of battle of sexes. Say if you choose different numbers here, okay, this is the NAS equilibrium. Okay, this is called low love, and this is high love. So based on the value. Okay. my question, can you find this NAS equilibrium? Yes or no? And can you practice probabilities high log and low log?
Hello, Prof. Are you
Yeah.
asking for us to do it as an assignment or?
No, the assignment is different. Can you check the
Ah,
last one? Okay, so practice first. I want to make sure that you know. Okay, and then you can do the assignment. Oh, okay, I understand what you're asking. The time is up. Okay, thank you. Okay, so yes, okay. So please check the assignment. Okay, at the end of the slide, which is about traffic in the intersection. Yeah. Okay. The rest is actually a lot of practices. So if you practice first from this simple thing, then you will be able to do the assignment. The assignment is a little bit more complex than the practices. Okay. Okay. So and next week we will discuss the threat in the case, the threat and the credibility, and then cooperative games. It is also very important. Quick. So please do the assignment and read this. And so with this non-zero sum games and zero sum games this time. Thank you very much.
thank you, Prof.
Thank you, Prof.
Please read the next topic. Read threat credibility and cooperative game. They are very interesting. And also the class games. Okay. Actually very interesting. How are you going to control the society or the organization? So these are the very interesting topic. Okay. Close this one.